Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth.
Hello everyone, and welcome back to Physics with Beth and Beth. I'm Beth, and in this video we are going to be talking about unit vectors, which are something that sounds scary but will make your life so much easier as we go through this calculus-based physics curriculum. So first, an introduction on what unit vectors are. They'll often look like this, which has a lot of weird symbols and letters, and there's a lot going on here. We would read this as the vector r is equal to x I hat plus y j hat plus z k hat. These little triangles on top of the I, j, and k, we actually say as hats. That's not just me being silly, that's something that like actual scientist people do in the real world. Physicists shouldn't be allowed to name things ever. We named these hats, and then we named like particles that glue things together as gluons, and it's just, there's not a whole lot of creativity in much of the physics community when it comes to names. So we have x I hat, y j hat, and z k hat. I, j, and k are what we call unit vectors. They have a magnitude of 1 and they point in the directions of the x-axis, y-axis, and z-axis. And that's it. So all that they do is specify direction of a number. So x I hat is the x component of my r vector. It has a length of x and it points in the I direction or along the x-axis on a graph. Y j hat has a length of y and points in the j hat direction. Z k hat has a length of z and points in the k hat direction. This is just a very clear and lovely way of describing which direction and which magnitude all of your vectors point in. You specify the magnitude of every single direction individually, instead of doing some gross triangle trig combination cobbled together thing that requires you to then break that vector down into x and y components and then go on your way. It also makes a lot of arithmetic with those vectors very straightforward. So for example, if we were asked to add a couple of these vectors, like we are here in green, if we're asked to find vector r that's equal to the sum of vectors a, b, and c, with vectors a, b, and c being this. So vector a is 2i hat plus 2j hat, vector b is 2i hat minus 4j hat, and vector c is 3i hat plus 5j hat. Just a quick little review. Our vector A, if we were to draw it out like you guys might have been used to in either your old geometry or trig or physics 1 classes, might have looked something like this. It has an x component of 2 and a y component of 2. That's what the 2i hat and 2j hat mean. And in your old classes, you would have had to use the Pythagorean theorem to figure out the magnitude of your hypotenuse, to figure out the overall magnitude of A, which would have ended up being 2.83. And then you would have had to use an inverse trig function like inverse tangent to find out this angle here, which is 45 degrees. But we don't have to do any of this. So actually, I'm just going to erase him. But that's what A looks like. So whenever you add your different vectors that are written like this together, it's really straightforward. You just add like to like, apples to apples and oranges to oranges, x's to x's and y's to y's. It's lovely. So here, if I were to add a plus b plus c, to find the x component of r, I just add my i's together, and that's it. So 2 plus 2 plus 3 is 7. So the x component, or the ith component of my r vector, would be 7.0 I hat. And I have to specify this I hat. It can be tempting as you go farther along in this class to start dropping these, but they're essential because they tell you which direction each component of your vector is pointing in. So don't forget him, even though he's, just kind of tacked on the end. He's really easy to forget and leave off, especially as you get used to him. You can take him for granted. Don't, he's important. He serves a very critical purpose here. So the x component of r is just 2 plus 2 plus 3, which is 7 I hat. And then for our y component, we just have 2 plus negative 4 plus 5, so 2 plus 5 is 7, minus 4 is 3. So my r vector here is just 7.0 I hat plus 3.0 j hat. And there you go, that's it. You just add your x's together and your y's together, just combining like terms like you've done 1,000 times in your algebra classes. It's really not that bad, and it's why unit vectors are so lovely and so beloved by physicists. Subtracting is similarly straightforward. You just have to be careful not to drop those pesky negative signs. So if I'm subtracting vector b from vector a, so a minus b, then all I do is subtract my x's from x's and y's from y's, being sure not to drop that second negative sign. So what I mean by that is this. I have 4.0 I hat minus, oh goodness, minus 6.0 j hat is my first vector, and then I'm subtracting 2.0 I hat plus 2.0 j hat. So I subtract 2 from 4, so that means that my x component of r is just 4 minus 2 I hat. And then for my y component, I'm subtracting this as well. So we're subtracting our x and we're subtracting our y. You have to make sure that you're distributing this negative sign to both directions of your second vector. So that's the one thing that can be really easy to forget, especially if you're really zooming through once you're used to unit vectors and all of this is old hat for you. Just be careful not to drop that negative sign. I'm saying this as someone who has missed far too many points on my physics exams because I've dropped negative signs in places like this. So don't be me, be better. Okay, so that would be negative 6 minus positive 2. So that would just be negative 8.0 j hat. And that's it. So just add likes to likes or subtract likes from likes, and then you're done. And that is literally all we have on unit vectors. Thank you so much for sticking with us on all of that. If you have any questions, feel free to let us know in the comments. Miss Beth and I read every single one. Thank you so much for sticking with me through all of that, and happy physicsing.